Next, we need to discuss when functions are increasing, decreasing, and constant. So a function is increasing if on an interval I, so any interval on our number line, and if for any choice of x1 and x2 in I, x1 is always less than x2 means our y value is always less for y x1 than x2. So let's take a look. This function right here, this is increasing, right? It looks like it's going uphill. If I have x is 10 and x is 11, you can see the y values are also proportional. This is like y is a half. So when x is 10, y is a half, a negative half. And when x is 1, y is positive 1/2. So our y values are less than each other. That means it's increasing. A function is decreasing on an interval if for any choice of x1 and x2, x1's less than x2, but its y values, the y value for x1 is greater than the y value for x2. That's going to be something that looks like it's going downhill. So here's an example of something that's decreasing. So here I've got when x equals -5 and when x equals 7. At x equals 7, y equals 5, right? This is the points, sorry, -7, 5. And here I've got when x is -5, y is 0. This is a decreasing function because my x value is -7 is less than -5, and 5 is greater than 0. I always like to look at this and see, like, is it going downhill, right? Downhill means it's decreasing. Let's put in some nomenclature. Downhill means it's decreasing. Uphill means it's increasing. Constant means it's flat, right? So this is where it's constant. Here we have something that's like very slightly decreasing because it looks like it's going downhill. This is increasing. This section here is decreasing. And this section right here we didn't talk about, but it's increasing because it looks like it's going uphill. Local minima and local maxima can tell us a lot about the graphs of functions. So let's let f be a function defined over an interval and c be a number within that interval. A function has a local maxima at c if there is an open interval in I containing c such that f of c is greater than f of x for all x in this open interval, meaning this is the biggest y value in the interval. That's called a local maxima. So here we've got our little interval from x1 to x2, and for every y value in this interval at this point, when x is c, that's the biggest, so that's going to be a maximum. We can also have local minima. It's defined the same way, except f of c is less than or the smallest of all f of x. So if we have this interval from x3 to x4, we'll call this c2. It has the lowest y value, so this would be a local minimum. We can also have absolute minimums and absolute maximums. So if I have a function on an interval, if there's some number in that interval for which, some number u for which the y value is greater than all others in that defined interval, then it's an absolute maximum. If there's some v value in our interval for which f of v is less than every single y value for all of the x's in our interval, then we have an absolute minimum. These are also sometimes called absolute extrema or extreme values.